Strength of material law, stress is equal to sigma p by a. P means force load acting on a body by a means cross sectional area of the body. అయితే ఇలా SI units stress usually expressed as Pascal. 1 Pascal is equal to 1 Newton per meter squared. This is the megapascal, gigapascal as there. 1 megapascal is the 1 into 10 power of 6 n by meter square, 1 Newton per millimeter square. 1 gigapascal is 1 into 10 power of 9 Newton per meter square, 1 kilonewton millimeter square. స్ట్రెస్ అయిపోయింది. స్ట్రెయిన్ ఏంటంటే స్ట్రెయిన్ ఈజ్ డెల్టా ఎల్ బై ఎల్, అంటే చేంజ్ ఇన్ లెంత్ బై ఒరిజినల్ లెంత్ అనుకోవాలి. సో స్ట్రెయిన్కి ఇచ్చేది నో యూనిట్స్ ఏమి ఉండవు. అదేవిధంగా ఇక్కడ మనకి యంగ్స్ మోడ్యులస్ ఆఫ్ ఎలాస్టిసిటీ అని ఉంటాయి. టెన్సైల్ స్ట్రెంత్ అంటే టెన్సైల్గా ఉంటుంది, కంప్రెసివ్ అంటే కంప్రెసివ్గా ఉంటుంది, అది ఐడియా ఉంది. యంగ్స్ మోడ్యులస్ ఆర్ మోడ్యులస్ ఆఫ్ ఎలాస్టిసిటీ అంటే యంగ్స్ మోడ్యులస్ అన్నా మోడ్యులస్ ఆఫ్ ఎలాస్టిసిటీ అన్నా కూడా లోడెడ్ విత్ ఇన్ ఎలాస్టిక్ లిమిట్, స్ట్రెస్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు స్ట్రెయిన్. అంటే హుక్స్ లా స్టేట్ దట్ వెన్ మెటీరియల్ ఈజ్ లోడెడ్ విత్ ఇన్ ఎలాస్టిక్ లిమిట్ the stress is directly proportional to strain. That is called as the Hooke's law actually. Either that is sigma and sigma directly proportional to strain. Sigma is equal to Young's modulus into strain, or E is equal to sigma by E equal to formula in the P into L by A into delta L. అయితే ఈ అనేది కాన్స్టెంట్ ప్రపోర్షనల్ నోన్ యాజ్ యంగ్స్ మోడ్యులస్ ఆర్ మోడ్యులస్ ఆఫ్ ఎలాస్టిసిటీ అని చెప్పుకోవచ్చు. అదేవిధంగా ఇక్కడ ఏంటంటే షియర్ మోడ్యులస్ ఆఫ్ రిజిడిటీ. షియర్ మోడ్యులస్ ఆర్ మోడ్యులస్ ఆఫ్ రిజిడిటీ అంటే ఏంటంటే షియర్ స్ట్రెస్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు షియర్ స్ట్రెయిన్. టౌ డైరెక్ట్లీ ప్రపోర్షనల్ పై, ఆర్ టౌ ఈజ్ ఈక్వల్ సి పై. టౌ బై పై ఈజ్ ఈక్వల్ సి. The proportion is known as shear modulus or modulus of rigidity, also denoted by Ng. Stress in a bar due to its own weight. This is the Wx. The total elongation of the bar delta L is equal to WL square by 2E. అదేవిధంగా ఇక్కడ ఏంటంటే డయామీటర్, బేస్ డయామీటర్, అప్పర్ అండ్ హియరింగ్ ఫ్రీలీ elongation bar weight is given by delta is equal to WL square by 6E. Stresses in a bars of varying sections, delta L equal delta L1 plus delta L2 plus delta L3. P by E L1 by A1 plus L2 by A2 plus L3 by A3. Stress in a bars uniformly tapering circular section is the delta L is equal 4PL by pi E D1 D2. Load shared by bar P1 is equal to P into A1 E1 by A1 E1 plus A2 E2, or bar to P2 is equal to P into A2 E2 by A1 E1 plus A2 E2. ఈ విధంగా సిగ్మా 1 is equal to E1 by E2 into sigma 2, sigma 2 equal to E2 by E1 into sigma 1. The ratio of E1 by E2 is known as a modular ratio of two materials. Next, to stress due to change in temperature, thermal stresses. Increase or decreases temperature of a body is known as thermal stresses. Temperature stress is called strain temperature. అయితే delta L is equal to L alpha T. Rigid support expression prevented by thermal strain injuring the bar, E is equal to delta L by L, L alpha into T by L alpha T. అదే థర్మల్ స్ట్రెసెస్ E ఈక్వల్ టు ఆల్ఫా టీఈ. అదేవిధంగా సపోర్ట్స్ yield by an amount of equal to delta, the expansion has taken place, delta L equal L alpha 1 T minus delta. Thermal stresses in a bars of tapering section. Tapering section is circular bar of a uniform tapering section. ఇట్లా తీసుకున్నట్టయితే ఆల్ఫా టీ ఈడి1 బై డి2. ప్రైమరీ ఆర్ లీనియర్ స్ట్రెయిన్. ప్రైమరీ ఆర్ లీనియర్ స్ట్రెయిన్ అంటే ఏంటంటే డెల్టా ఎల్ బై ఎల్ ఈజ్ నోన్ యాజ్ ప్రైమరీ ఆర్ లీనియర్ స్ట్రెయిన్. సెకండరీ లాటరల్ స్ట్రెయిన్ అన్న అంతే ఉంటుంది. అదేవిధంగా పాయిజన్స్ రేషియో. ద రేషియో ఆఫ్ lateral strain to linear strain is called Poisson ratio. Volumetric strain. Change in volume to original volume is known as volumetric strain. Delta V by V, P by BTE 1 minus 2 by M equal to E of 1 minus 2 by M. Bulk modulus. The cube is subjected to 3 mutual perpendicular tensile stress equal to intensity the volumetric strain. Delta V by V equals 3 sigma by E 1 minus 2 by M. The relation between bulk modulus and Young's modulus is given by K is equal to ME of 3 of M minus 2. The relation between the modulus of velocity E and modulus of rigidity is given by C is equal to ME by 2 of M plus 1. And relation between C E K given by E equal to 9kc by 3k plus C. Bearing stresses, crushing stresses. Sigma B, sigma P by delta T, P by dTn. Principal stresses and strains. Principal stresses and strains అంటే మనకి స్ట్రెస్ స్ట్రెయిన్ డయాగ్రామ్ వేసుకోవాలి. ఇక్కడ సిగ్మా ఎన్ ఫోర్స్ నార్మల్ సెక్షన్ ఈఎఫ్ ఏరియా ఆఫ్ సెక్షన్. ఇక్కడ ఏమొస్తుంది సిగ్మా కాస్ స్క్వేర్ టీటా. Stresses and abrasions of the body subject direct stress in one plane is the sigma cos square theta. Tangential stress across the EF, force along section EF అంటే ఇక్కడ ఏమొస్తుందంటే ఏరియా ఆఫ్ సెక్షన్ అంటే సిగ్మా ఏ సైన్ టీటా బై ఏ సెకండ్ టీటా సిగ్మా సైన్ టీటా ఇంటూ కాస్ టీటా వస్తుంది. ఇంకా సిగ్మా బై 2 ఇంటూ 2 సైన్ 2 టీటా కాస్ టీటా ఎక్కువ సిగ్మా బై 2 ఇంటూ సైన్ 2 టీటా వస్తుంది. అయితే ఇక్కడ ఏంటంటే ఈఎఫ్ విల్ బి మ్యాక్సిమం కాస్ స్క్వేర్ టీటా ఈక్వల్ 1 కాస్ టీటా ఈక్వల్ 1 టీటా ఈక్వల్ 0. Maximum normal stress sigma n is equal to sigma cos 0 degrees is sigma. Tau max maximum tangential shear stress tau max equals sigma by 2 sin 90 degrees equals sigma by 2. One of the maximum normal stress, the resultant stress is given by sigma r sigma n whole square plus tau square. The above relation holds good compressive stress also. ikkadenti stresses on oblique section of body subject to direct stress in two mutual perpendicular directions. ఇక్కడ మ్యూచువల్ పర్పెండిక్యులర్ డైరెక్షన్ ఏంటంటే సిగ్మా ఎన్ ఈజ్ ఈక్వల్ సిగ్మా ఎక్స్ ప్లస్ సిగ్మా వై బై 2 ప్లస్ సిగ్మా ఎక్స్ మైనస్ సిగ్మా వై బై 2 కాస్ 2 టీటా. టాంజెంటల్ స్ట్రెస్ ఏంటంటే ఈఎఫ్ స్టవ్ ఈజ్ ఈక్వల్ టు సిగ్మా ఎక్స్ సిగ్మా వై సైన్ టీటా కాస్ టీటా ఈక్వల్ టు సిగ్మా ఎక్స్ మైనస్ సిగ్మా వై బై 2 సైన్ 2 టీటా. రిజల్టెంట్ స్ట్రెస్ ఏమొస్తుంది సిగ్మా ఆర్ సిగ్మా ఎన్ హోల్ స్క్వేర్ ప్లస్ టో స్క్వేర్ ఈక్వల్ టు సిగ్మా ఎక్స్ కాస్ స్క్వేర్ కాస్ టీటా స్క్వేర్ ప్లస్ సిగ్మా వై సైన్ 2 టీ స్క్వేర్ సైన్ టీ స్క్వేర్. మ్యాక్సిమం being cos 2 theta equal 1 theta equal 0. Cos 2 theta equal minus 1 or 2 theta 180 degrees theta equal 90 degrees. ఈ విధంగా టౌ మ్యాక్సిమం అయితే ఏమైందంటే మ్యాక్సిమం ఆన్ టూ ప్లేన్స్ ఇంక్లైన్ 45 degree 135 degree నార్మల్ సెక్షన్. ద మ్యాక్సిమం స్ట్రెస్ ఇన్ టైట్ ఆఫ్ 45 degrees to 135 degrees. అదేవిధంగా మ్యాక్సిమం సైన్ 2 theta is equal అయితే ఓకే టౌ మ్యాక్స్ సిగ్మా ఎక్స్ మైనస్ సిగ్మా బై 2. ఈ విధంగా ఇది ద స్ట్రెస్ ఆన్ అబిలిక్ సెక్షన్ ఆఫ్ ఎ బాడీ ఇన్ ప్లేన్ అకాంపౌండ్ సింపుల్ షియర్ స్ట్రెస్ ఏమైందంటే సిగ్మా ఎన్ మ్యాక్స్ వచ్చేసి టెన్సైల్ స్ట్రెస్ ఇన్ వన్ ప్లేన్ అకాంపౌండ్ బై ద వన్ ప్లేన్ అంటే సిగ్మా ఎక్స్ బై 2 ప్లస్ సిగ్మా ఎక్స్ బై 2 హోల్ స్క్వేర్ ప్లస్ సిగ్మా ఎక్స్ బై హోల్ స్క్వేర్ ఈక్వల్ టు సిగ్మా ఎక్స్ బై 2 ప్లస్ 1 బై 2 సిగ్మా ఎక్స్ స్క్వేర్ ప్లస్ 4 టౌ ఎక్స్ స్క్వేర్. ఈ విధంగా వస్తుంది. నెక్స్ట్ minimum normal stress sigma n minimum sigma x by 2 minus sigma x by 2 whole square plus tau x square by sigma x by 2 minus 1 by 2 sigma x square plus 4 tau square x square. ఇది maximum shear stress. sigma n max minus sigma n minimum by 2 sigma x by 2 whole square plus tau x square whole square under root equal 1 by 2 sigma x square plus 4 tau x square. When the expression 1 by 2 sigma x whole square plus tau x by tau x square is greater than sigma x by 2, the opposite that tensile will be compressive and vice versa. Stresses an oblique section of a body subject to direct stresses to mutually perpendicular direction accompanied by a simple shear stress. Sigma x plus sigma y by 2 sigma x minus sigma by 2 whole square plus tau x square whole square equal to sigma x plus sigma by 2 plus 1 by 2 sigma x minus sigma y whole square 4 tau x whole square. Minimum normal stress is the sigma x plus sigma by 2 minus sigma x minus sigma by 2 whole square tau x square equal sigma x plus sigma by 2 minus 1 by 2 sigma x minus sigma y whole square plus tau 4 tau x square whole square under root. And maximum shear stress sigma n max minus sigma n minimum by 2 sigma x minus sigma y by 2 whole square plus tau square x y under root 1 by 2 sigma x minus sigma y whole square plus 4 tau x y whole square. This is the Mohs cycles of stresses when two mutual perpendicular planes are equal tensile and principal stresses rectangular required. Mohs cycle తీసుకుంటే డయాగ్రామ్ తీసుకోవాలి. ఇట్లా ఇక్కడ ఏమి ఇచ్చిందంటే notes horizontal diameter, therefore maximum normal stress will be equal to sigma x and the minimum principal stress will be ఇది అవసరం లేదు. ఓకే మోస్ట్ రెసిలియన్స్ The maximum energy resilience, the strain energy stored in a body due to external loading within elastic limit is known as resiliency. The maximum strain energy which can be stored in a body up to elastic limit is called proof resiliency. The proof resilience per unit volume material is known as modulus of resiliency. Okay, the strain energy stored in a body is subject to direct tensile and compressive load sigma square by 2e into v, and modulus of resiliency is sigma square by 2e. ఇక్కడికి వచ్చేసి ఏంటంటే ద స్ట్రెయిన్ ఎనర్జీ స్టోర్ ఇన్ ఏ బాడీ వెన్ సబ్జెక్ట్ టు షియర్ స్ట్రెస్ అయితే టౌ స్క్వేర్ బై 2c ఇంటూ వి. మోడల్స్ ఆఫ్ షియర్ రెసిలియన్స్ is టౌ స్క్వేర్ బై 2c. Stress induced in body under different modes of loading is when load W applied gradual body stress induced body is given by sigma equal W by A. When load applied suddenly body stress induced body induced same load applied 2 into W by A. When a body dropped cross sectional area stress induced is given by W by A 1 plus root of 1 plus 2 HAE by WL. ఈ బీమ్స్ ఏంటంటే ఒకసారి ఇంపార్టెంట్ బీమ్స్. క్యాంటిలివర్ బీమ్, ఏ బీమ్ ఫిక్స్డ్ at one end is free and other end is known as cantilever. Simply supported beam, both ends is known as simply supporting. Both ends is known as simply supporting. Supported both ends. Overhanging beams, a beam having end position extended beyond the support is known as overhanging beam. A overhanging beam one side on both sides are there. Fixed beam, a beam whose both ends are fixed is known as fixed beam. Continuous beam, a beam supported one more two supports is known as continuous beam. Type of loading, concentrated point load and uniformly distributed load. The shear force and bending moment diagrams is there. This is the cantilever beam, SFD. This is the rectangular shape. This is the linearly bending material linearly. So and again this one also same. Gradually varying load, simply only. Bending equation, beam simply bending m by e sigma by e by r. The line intersection generally a normal cross section beam is known as a neutral axis of the section. Composition of the side this. From the bending equation m by e sigma by y, m equal to sigma into I by y, m equal to sigma into z. Beams of uniform strategic section modulus. This is E1 by E2 is the modular ratio. Shear stress in beam. Shear stress in a beam, the maximum shear stress developed with the beam rectangular cross section. Tau max 1.5, tau average shear stress equal load by area. The maximum shear stress developed in a beam circular cross section is known as the figure is given. Tau max equal 4 by 3 tau average. This figure. Deflection beams m equal EA d square y by dx square. Simply supported beam, the central point load is the central point load WL cube by 48 EA. Simply supported beam with the eccentric point load అంటే ఇట్లా ఉంటుంది. So eccentric point load equal to WAB by 6 EA L square minus A square B square WA square B square by 3 EA. Since B greater than A, deflection occurs CB from the x equal to L square minus A square by 3. The maximum deflection Y max equal to WA by 9 root 3 EIA L square minus A square root of 3 by 2. Simply supported beam with uniform distributed load ఈ విధంగా ఉంటే the maximum deflection occurs midpoint C is given by 5 WA power 4 384 EA equal 5 WL cube by 384 EA. Simply supported beam with a gradually varying load ఇట్టుంటే y is equal to 1 by EA WL x cube by 36 minus WX by 5 120L 7 WL cube x 360. The maximum deflection occurs when x equals 0.519 L. Value is given by y max equals 0.00652 WL power 4 EA. Cantilever beam with a point load of free end ఈ విధంగా ఉంటే ఇట్లుంటే y equal 1 by EI WL square x by 2 minus WX cube by 6 minus WL cube by 3. The maximum deflection occurs free and x equal to 0. Value is given by yb equal to w to 3a. Cantilever beam with uniform distributed load ante y equal 1 by a wl cube x by 6 minus wx power 4 by 24 minus wl power 8. The maximum deflection occurs free and the value given wl by 4 by 8 ea equal to wl cube by 8 ea. In cantilever partial loaded, deflection of the beam yc is the wl power 4 by 8 ea. The maximum deflection occurs b. This point is the b 7 wl power 4 by 384 ea. Cantilever beam gradually varying load 1 by e wl cube by x 24 minus wx power 5 120 l wl power 30. The maximum deflection occurs end is the wl power 30 ea. Fixed beam varying a central point load is equal to wl cube by 192 ea. Fixed beam carrying an eccentric point load wb square x square by 6 eal cube x into 3a plus b minus 3al. Maximum deflection occurs when x equal to 2al by 3a plus b. Maximum deflection y max equal to 2 by 3 into wa square b square ea 3a plus b square square. The deflection under load 3 wa cube by b cube 3a. Fixed beam carrying uniform distributed load 1 by ea wlx cube by 12 minus wx power 24 minus wx square x by 24. The maximum deflection occurs in the center of the beam wl power 4 3 by 8 384 ea wl cube by 384 ea. Shear stress in a shaft shear stress shaft torsion t by t tau by r equal t by j equal c theta by l. To x by tau by r. The strength of shaft maximum torque power transmitted by the from equation t is equal to tau into j by r. T is equal to tau into pi d power 4 by 32 into dv pi by 16 into pi d cube. The internal action polar moment of inertia j equal pi by 32 d power 4 minus d power 4 r is equal to d by 2. T is equal to pi by 16 into tau d power 4 minus d power 4 d equal pi by 16 into tau into d cube by 1 minus k power 4 where k is equal to d by d. Term j by r is known as polar modulus. The polar modulus of solid shaft Zp equal pi by 16 d cube. Polar modulus of hollow shaft Zp equal pi by 16 d power 4 minus d power 4 d. In term t by t is known as a torsional rigidity of the shaft. The power transfer of the shaft is given by p equal to t w 2 pi nt by 60. Strain energy due to torsion strain energy to solid shaft diameter length u is equal to tau square by 4c into v. The volume of the shaft pi by 4 into d square into l. The total strain energy stored in a hollow shaft external diameter internal diameter of the given by u is equal to tau square by 4c d square plus d square by d square into v. Shaft subject to combined bending and torsion. Twisting moment 1 by 2 sigma b plus sigma square b plus 4 tau square. The minimum normal stress is sigma b 1 by 2 sigma b minus sigma b whole square plus 4 tau square. 4 tau square. You know that the shaft diameter sigma b 32 m by pi d cube and tau is equal to 16 d by pi d cube. Substituting these values, maximum normal stress is the 32 by pi d cube 1 by 2 m plus m square plus t square equal to 16 by pi d cube m plus m square plus t square. The minimum normal stress tau minimum is 32 by pi d cube 1 by 2 m minus m square plus t square 16 by pi d cube m minus m square plus t square. The x1 by 2 m plus m square plus t square known as equivalent bending moment and me. We know that maximum shear stress in shaft is tau max equals sigma b max minus sigma b minimum by 2. 1 by 2 sigma b whole square plus tau square 16 by pi d cube m square plus t square root of. The expression m square plus t square is known as equivalent twisting moment denoted by Te. For a hollow shaft external diameter, internal diameter, the maximum normal stress is sigma b max 16 d by pi of t power 4 minus d power 4 m plus m square plus t square. Minimum normal stress sigma b minimum 16 d by pi of t power 4 minus d power 4 m minus m square plus t square. Maximum shear stress is tau max equals 16 d by pi of t power 4 minus d power 4 m square plus t square. This is the springs is there. Stiffness of the spring. Spring is called stiffness in the load required to produce the deflection of the spring. Carry spring leaf spring sigma equal to 3 wl by 2 n bt square. The stress this is deflection is the 3 wl cube by 8 en bt cube. Closely coiled helical spring T equal WR, W into D by 2 pi by 16 into pi T by cube. Deflection of the spring 6 W equals 64 WR cube N by CD power of 4, 8 WD cube N by CD power of 4. Energy stored in the spring U equal 1 by 2 W delta. Stiffness of the spring S equal W by delta CD power of 4, 64 R cube N CD power of 4 by 8 D cube N. Main radius of the spring called D by 2. Spring in the parallel 1 by K equal 1 by K1 plus 1 by K2. K equal K1 K2 by K1 plus K2. When the spring is connected in the parallel is shown in the figure. K equal K1 plus K2. Riveted joints. Lap joint and butt joint is there. Single trap joint. This is the double trap joint is there. Back pitch, diagonal pitch. Center riveted distance lower, so riveted joint is there. It is the perpendicular distance between the center line of the successive rows. This is the back pitch. Diagonal pitch is the distance between the center of rivets adjacent rows. Zigzag riveted joint. Marginal pitch is the distance between the center riveted hole to the nearest edge of the plate. Tearing of the place across the rivets, the tearing resistance pulled the plate per pitch length is the P equal P minus D T of sigma T. Shearing of rivets B as equal N into pi by 4 D square into D, N into 2 pi by 4 D square into T. Crushing of rivets, pull or crush rivets is the PC and D T sigma. Least value of T, PS, PC by PT sigma T. Welded joint. The strength transfer fluid welded joint is the P is equal 1 by root 2 SL delta T and root 2 SL sigma T. For single fillet welded, double fillet welded is there. This is the single fillet welded, double fillet welded. The strength of parallel fillet weld joints is given by 1 by root 2 SL sigma. For single parallel fillet weld, root 2 SL for double parallel fillet weld. Transfer fillet weld joints are designed for tensile strength. Parallel fillet weld joints are designed for shear strength. Thin cylindrical spherical shell. A thickness of wall shell less than 1 by 10 to 1 by 15 diameter is known as thin shell. And circumferential hoop stress, longitudinal stress. Sigma C is the circumferential hoop stress PD by 2Tn. For longitudinal stress is sigma D PD by 4Tn. The circumferential stress tendency to split the cylindrical shell into two throats. The longitudinal stress has tendency to split the cylindrical shell into two cylinders. The longitudinal stress half of the circumferential hoop stress. Change in dimension of thin cylindrical shells. Sigma C circumferential strain PD by 2Te 1 minus 1 by 2m. Longitudinal strain PD by 2T 1 by 2 minus 1 by m. Change of diameter is given by delta T EC PD square by 2T 1 minus 1 by 2m. Change in length delta L equal PDL by 2T 1 by 2 minus 1 by m. Change in volume delta V equal V of 2EC EL V equal pi by 4 D square L. dV by V 2EC plus EL equal PD by 4TE 5 minus 5 4 by 4 by m. This is the volumetric strain. The spherical shells is the sigma equal PD by induced shell material PD by 4Tn. The change in diameter given by delta D PD square by 4D 1 minus 1 by m. The change in value pi of PD power of 4 8TE 1 minus 1 by m. Thick cylindrical shell, spherical shell. Thickness of wall shell is greater than 1 by 10 to 1 by 15 diameter is called thick shell. Direct bending stress is sigma B P by A. Magnitude of bearing edge sigma B PE YC by I. PE YE by I. This is the second moment of inertia. Second moment of inertia section, but the neutral axis is y axis dB cube by 12. The maximum resultant compressive strength sigma B by sigma naught, and this is the maximum resultant tensile strength Py by minus P by A m by Z minus P by sigma B. Okay, limit of eccentricity m by Z minus P by A. Tensile strength is there. For hollow rectangular, okay, for rectangular section width depth E eccentricity less than or equal D by 6. For a hollow rectangular section B and D with depth respectively D inner with diameter A eccentric BD cube minus BD cube by 6D BD minus BD. For circular section of diameter D eccentricity E less than or equal D by 8. For a hollow circular section outer diameter is the E less than D square plus D by 8D. Columns and struts is there according to Euler's formula. For both hinged P equal to pi square EA by L square, one fixed, other end phi is the pi square EA by 4L square. Both fixed is the 4 pi square EA by L square. For one fixed, another hinged is 2 pi square EA by L square. Euler's formula pi square EA by CL square. C equal to 1 for column with both ends hinged. C equal 4 for column with 2 minutes. When end fixed, other end is free. C is equal 4 for a column with one end is fixed, other end is free. C equal 1 by 4 for column with both ends fixed. C is equal 1 by 2 column with one end is fixed, other end is hinged. దీంట్లో ఫార్ములాస్ ఏంటంటే both ends hinged pi square EA by L square, pi square EA by L square, L is equal to 1. One end is fixed, another end is free. Pi square EA by 4L square, pi square EA by 2L square, pi square EA by L square, L equal 2L. Both ends fixed is L equal 1 by 2 pi square EA by L square. One end is fixed, other end is hinged is pi square EA by L square, 1 L equal 1 by L by root 2. The Euler's formula is given by pi square EA by L square, pi square EA by L by K whole square. I is equal to AK square, the least radius of gyre section. 1 by K is known as slenderness ratio. Sometimes column whose slenderness ratio more than 8 is known as long column. Those whose slenderness ratio less than 8 is known as short column. Euler's formula holds good only for long column. Euler's formula only for Rankine's formula. Rankine's formula P is equal to sigma C by A 1 plus A L by K whole square. Rankine constant sigma C by pi square EA. For Rankine values of constant. For wrought iron is the A equal to 1 by 9000. For cast iron is the A equal to 1 by 1600. For mild steel is the 1 by 7500. For timber is the A equal to 1 by 750. Dams and retaining walls. The weight of the dam per unit length W equal A plus B by 2 into H into 1 into P. The pressure unit length trapezoidal dam is P is equal to WH square by 2. Horizontal distance between center of gravity with constant P by W into H by 3. The distance between the dam AG plus P by 2 H by 3. Sigma max W by B maximum stress. In case of B maximum stress W by B 1 plus 6E by B. Sigma minimum W by B 1 minus 6E by B. Plus or minus is maximum. Maximum is the plus, minimum is the minus. In order to avoid dam force friction is the dam should be at least 1.5 times total water pressure in the meter length. Rankine's theory of active earth pressure according to horizontal thrust retaining the P is equal to WH square by 2 1 minus sin pi by 1 plus sin pi. P equal to P of 1 minus sin pi by 1 plus sin pi. Peak intensity of supercharged pressure. Supercharged load is given by P of 1 minus sin pi by 1 plus sin pi. Reinforced cement, this is this. Elastic material, plastic material, ductile material, brittle material. Elastic material is the original position, removal of the external force is called elastic. Permanent not regain its original position. Ductile is the deformation. Brittle material cannot undergo deformation. Rupture. Ultimate to stress is the ultimate load by original cross-sectional area. Breaking stress is breaking load by original cross-sectional area. Percentage reduction area, original area minus final area by original area into 100. Percentage length final length minus original length by original length 100. The tensile stress performed ductile material is compression test is performed on brittle material. The ratio of ultimate stress and the working stress is known as factor of safety value as more than 1. Elongation of uniform rod length L due to its own weight WL by 2AA. Total extension produced rod length due to lower weight per unit length WL square by 2EA. And elongation of tapering rod 4PL by pi EDD PL by A temperature limit E alpha T, normal stress P cos square theta, tangent stress P sin 2 theta by 2, normal stress P1 plus P2 by 2 plus P1 minus P2 by 2 cos 2 theta, tangent stress P1 minus P2 sin 2 theta by T, normal stress P cos square theta, tangent stress P sin 2 theta by T. Resilience strain energy is S square by 2 into volume by stress. Modulus of resiliency less than the sigma square by 2e. Strain energy S square by V is 2g. Rotational ratio 1 by m. Volumetric load E P by E 1 minus 2 by m. Bulk modulus E equal to 2g of 1 plus V. Volumetric stress into 3 into linear strain. Rotates increase pressure until the corresponding decrease in volume. K is equal to 2g of 1 plus V. K is equal to E by 3 of 1 minus 2V. E equal to 9gk by 2k plus g. Strain 2 log E d0 d1. True strain. Sectional work of impact stresses 1 by 2 as SL by E 1 by 2 S square by E AL. A factor of 1 by 2 S square by E. Stress produced load P falling from height S plus S root of 1 plus 2H by EL. Above expression is also written by A by P 1 plus 2AH by PL. Strain energy restored due to stress 3 directions 1 by 2E S square minus 2 by M S6. Okay. Equal stress in 3 S square by 2E 1 plus 2 by M S square by 2K. Also known as volumetric strain energy. General 2-dimensional is this there equation tan 2 take 2S by S by minus principal strains. Okay. F is elastic limit by actual stress. Strain energy theory used for ductile material STA by L S1 square S2 square S3 square minus 2V S1 S2 S2 S3 S3. Fs is the S1 minus S2 whole square plus S2 minus whole square plus S3 S minus whole square by 2. Bending stress in beams M by I S by E by R. Q equal to dm by dx. Q equal to FD by W. M by E d square y by dx square. Equation of deflection curve. Strain energy equal to M square by 2E dx. D max WL power 4 8EA. Dow max equal 4 WL cube by 8EA. WL cube by 48EA. This is the simplest subload means eccentric load. Load Dow max 5 by 384 WL cube 48. Torsion T by J G theta by L SSR by 16 T by pi d cube. Torque capacity को pi d cube by SS 16. Over capacity को pi square N d cube by 8 N SS. Angle of T is 32 TL by pi G d power 4 rad. SS 16 T d by pi of d power 4 d power pi of d power 4 d by 16 T. T SS here P equal pi square N d power 4 minus d power 4 by 8 D into SS T equals 32 TL by pi G d power real. అదేవిధంగా టీ గ్రేడ్ అయితే 1.8 బి ప్లస్ 3 డి ఇంటూ టీ బీ స్క్వేర్ బై డి స్క్వేర్ దిస్ మిడిల్ సైడ్ ఆఫ్ బి 7 టీఎల్ బీ స్క్వేర్ డి స్క్వేర్ బై 2 జీ క్యూబ్ బై డి క్యూబ్ టీ బై 2 టీఏ 3 టీ బై డి స్క్వేర్. ఓకే. This box is important here. This box also important. This box also important. D square by D square. Divided cube by M plus M cube D square. Maximum shear stress, minimum shear principal player in the theta equal 1 by 2 tan inverse of T by M. For combined loading equivalent bending moment M plus M square by T square by 2. Equivalent torsion is M square plus T square. Springs 8 PD by helical swing shear stress injury 8 PD by pi d cube. Axial deflection 16 PR cube N by GD cube. Stiffness swing is swing constant GD power of 4 by 64 R cube N. R is equal to D by 2. When the coiled swing is subject to an axial coupled rotation 64 MDN by ED power of 4. S1 by S2 32. Delta is in case of 3 PL cube by 8 EN BD cube. S max is equal to 3 PL by 2 N BD cube. diagrams also important. S max bolt is there, P by 2TA whole square, 16 by pi d whole square. PL R1 square plus square, build bracket stress bolts. Similarly, P2 by S1 by 1 by 2 S2 whole square. Welded joint is there. Fillet weld parallel FLDL weld through 0.7 W weld transverse loading F by TL through T equal 0.77 W constant into T. S equal F by A resultant stress S by A square M by Z. Welded bracket subject to T by R into J F by A. Deflection of beam WLK by 192 EA, pi square E by 1 by K square is the column percent ratio. Both ends injured pi square EA by L square V, actual length L, one end is fixed, other end is free, pi square EA by 4L square, 2L, both ends fixed, 4 pi square EA by L square, L by 2, one end fixed and one end is hinged, 2 pi square EA by L square, L by root 2, one end fixed compressed lateral, another end is fixed directionally, pi square A by L square, this is the L. Rankine coordinates from SC by A, 1 plus A, 1 by K square, S A equal to SC by square equal. Johnson's parabolic equation is there. P into R by T, longitudinal PR by 2T. This one is this spherical PR by 2, circumferential PR by 2T, strain PR by 2T, 1 minus 1 by M. Volumetric strain EV sigma 3 3PR by 2TE 1 minus 1 by M. Okay, theory completed. Thank you.